Intermediate Algebra for Statistics, Integer Exponents Part 4, Lesson Objectives, Use models whose equations involve negative integer exponents, use scientific notation. Lesson Objective, Exponential Function, Introduction. Examples of exponential functions are f of x equals 2 times 3 raised to the x power, g of x equals negative 7 times 1/2 to the x power, and h of x equals 5 to the x power. So in this chapter we will use the exponential function to model data. All three of these functions are an example of an exponential function. The key is the base is a number, a numeric value, and the power is the variable. That is what makes an exponential function. Definition: an exponential function is a function whose equation can be put in the form f of x equals a times b to the x power, where a cannot equal 0, b has to be a positive number, and b does not equal 1. The constant is called the base. B can't be equal to 1 because this will become a linear function. Example 8. For f of x equals 3 times 2 to the x power and g of x equals 5 to the x, find the following. Number 1, f of 3. Number 2, f of negative 4. Number 3, g of the expression a plus 3. And number 4, g of 2a. Solution: f of 3, our input is 3. We want to find the output. Everywhere we see an x, we substitute a 3. Now we need to evaluate this. Order of operation says we do exponents before we multiply. So 2 to the third is 8. We multiply it by 3 and we get 24. So for this function, when the input is 3, the output is 24. Number 2, f of negative 4. We substitute negative 4 for x. Now we need to evaluate what is 2 to the negative 4 before we multiply by 3. 2 to the negative 4 power, it's in the numerator. We have to send it to the denominator to make it positive. Or you can think of the reciprocal. So we have 3 over 2 to the 4th. 2 to the 4th is 16. So our answer is 3/16. We can use the graphing calculator to verify the answers. So for number 1, 3 times 2 to the 3rd power is 24. Number 2, 3 times 2 raised to the negative 4 power is 0.1875, which if we change that to a fraction is 3/16. It checks. For number 3, everywhere we see an x, we substitute a plus 3. Now when we add exponents, that means we are multiplying like bases. So we can split this up to 5 to the a power times 5 to the 3rd power. 5 to the 3rd power is 125, and we normally write the number first, then the base, and then the power. So this will become 125 times 5 to the a power. G of 2a equals 5 raised to the 2a power. So when we have two numbers that are multiplying with a base, that means we have a power to a power. So it doesn't matter really which one you write inside or outside. They'll both be equivalent. 5 squared is 25. So we have 25a. And we are finished. Lesson objective: scientific notation. Introduction. Exponents are very useful when we use scientific notation. Scientific notation allows us to represent very large or very small numbers. Scientific notation is used a great deal in science, classes like chemistry and physics, where we are talking about a long distance, maybe from the Earth to the Sun, or very small numbers like the length of an atom. In scientific notation, this symbol is used for multiplication. Now, chances are you probably have seen scientific notation before. This is how we will define it for this class. It's a number that can be written in the form n times 10 to the k, where k is an integer, and either n is in between -10 and -1, or n is in between 1 and 10. Now this will make more sense once we do a few problems. We use a power of 10 because 10 is easy to work with, both multiplying and both dividing. Let's look at an example. If we had 3.1 and we multiply it by 10, we get 31. If we had 3.1 and we multiply it by 100, we get 310. If we take 3.1 and multiply it by 1,000, we get 3,100. When we multiply by powers of 10, we simply move the decimal place to the right. 3.1, if we move it one decimal place, it becomes 31. If we move the decimal place 2 places, it becomes 310. If we move it 3 decimal places, it becomes 3,100. So multiplying by 10 is very easy. We just move the decimal place to the right. If we divide by 10, 3.1 divided by 10 is 0.31. 3.1 divided by 100 is 0.031. 3.1 divided by 1,000 is 0.0031. So when we are dividing by a power of 10, we move the decimal place to the left. Now, dividing by powers of 10 is the same thing as multiplying by powers of 10 raised to the negative power. And we'll see that in some examples. Example 9. Number 1. 5 times 10 to the third. 5 times 10 to the third. We evaluate this first, then we multiply. 10 to the third power is 1,000. 5 times 1,000 is 5,000. So one way of thinking of this is we simplify the expression by multiplying 5 times 10 3 times. That's the same thing as moving the decimal point 3 places to the right. So this is scientific notation. In this case, n is 5 and k is a positive 3. This power here tells me the number of places to move the decimal point. So since this is a 3, I'm going to take the decimal point and move it 3 places to the right. It becomes 5,000. Number 2, 5 times 10 to the negative 3. 10 to the negative 3 is equal to 1 over 10 to the third. 10 to the third is 1,000, so this is 5 times 1 over 1,000. To multiply fractions, we take the product of the numerators over the product of the denominators. We get 5 over 1,000, and 5 over 1,000 using a calculator is 0.005. Simplify 5 times 10 to the negative 3 by dividing 5 by 10 3 times. Or, that's the same as moving the decimal point 3 places to the left. Here's the decimal point for 5. Since we are multiplying by a negative 3, we can move that 3 places to the left because the number will be smaller. So from converting scientific notation to standard notation, we write the scientific notation n times 10 to the k in standard decimal notation. We remove the decimal point on the number n as follows. If k is positive, we multiply n by 10 k times, or we simply move the decimal point k places to the right. If k is negative, we divide n by 10 k times, or we simply move the decimal point k places to the left. So if k is positive, the number will be bigger. We move the decimal point k places to the right. If k is negative, we move the decimal point k places to the left. The number will be smaller. Example 10. Write the number in standard decimal notation. Number 1, we have 3.462 times 10 to the 5th. And number 2, 7.38 times 10 to the negative 4. Solution: we multiply 3.462 by 10 5 times, or we simply move the decimal point 5 places to the right, because in this case k is a positive 5. Moving this 5 decimal places means we have to add 2 zeros, and then we put our decimal point. Number 2, we divide 7.38 by 10 4 times, or we can simply move the decimal place to the left 4 places because k is a negative 4. So here's the decimal place. To move it 4 places means we need 3 zeros in front of the 7. So this number is now smaller, 0.000738. We can verify this using a graphing calculator. If we take 3.462 times 10 to the 5th, we get 346,200. And if we take 7.38 times 10 to the negative 4, the calculator is stating scientific notation. So when you see this on the calculator, the E means I'm multiplying it by 10 to this power. So 7.38 times 10 to the negative 4 is the same thing as 7.38 e to the negative 4 as far as notation on the calculator. Thanks for watching.